Let's take a look at this synthesis problem. In this case, we're starting with a combination of a ketone and an alkyne, and we're just adding 2 carbons to it as an ethyl group. Normally, we'd think, okay, well, we've got an alkyne, we have our nucleophile already, basically. We just need to deprotonate it, and poof, we have our nucleophile. Throw in some ethyl bromide or something, and we're done. The problem is, however, as soon as we have that anion, as soon as we have that, before we can even add in our ethyl bromide, what will happen is it's going to go ahead and find another molecule of the same type, and it's going to go ahead and want to attack it, opening up our carbonyl. So we have the problem of side reactions happening. While we haven't also yet learned this, by the way, the protons on ketones are particularly acidic, the alpha protons, so we also have a competing reaction there, although this is not one we're going to see to the end of the semester, towards the end at least. So we have another problem there where it could just abstract another proton, and now we have a problem. So, answer to this is, we need a functional group protected. Protection to happen. And in this, we remember that, we can protect ketones by making them into acetals. So, we know that this last step can be done by having our acetylide ion attacking, we'll say, ethyl bromide, or something like that. Let me draw it a little bit better just so we have a little bit easier place to see. So it's going to be a typical SN2 reaction. So with this, we know, you can attack this ethyl group, kick out the bromine. That's how we're going to get that ethyl group on there. But the problem is that ketone there will not allow us to do it. So we need to protect that ketone. Best way to do that is using an acetal, or in this case it'll be a ketal actually, but same idea, so a diether. Typically symmetrical ones are used, but you don't have to. You could use a regular, methanol. That would work just fine. Not a problem to use that. And so with this, we see, we can go ahead and have this reaction attack as long as we protect that ketone. And so if we want that to happen, the last step then should be a deprotection. Because we know we have the carbon-carbon bond forming step here in this SN2 reaction, where our acetylide attacks the ethyl bromide. And so our last step then should be to deprotect. And if you remember how to deprotect a ketal, or an acetal, same reagents, you need water, acid, and heat, and that'll deprotect your ketal. We know that we needed this acetylide to attack the ethyl bromide, so that'll probably be the step right before this. So once we have this kind of attached, if we're doing this retrosynthetically, we'll have our ethyl group on there. We saw that we needed that ethyl group to get on in the presence of the ethyl bromide. We just needed the acetylide version. Remember that there's always a counter ion with that. And of course, the acetylide we get by using sodium amide. That one will deprotonate our acetylide. That's also a problem because we have a very strong base here that could be nucleophilic. And as we'll see with nitrogen nucleophiles, we want to avoid that. So again, ketone is vulnerable here. So with it protected, though, we have none of these worries. All right, so that's just with the hydrogen there at the end instead of the acetylide. And then if we want to put that protecting group on, we just need our alcohol, H+, and heat. You can do this with excess ethylene glycol. That'll just make sure that it goes all the way to completion, since there's no other competing things. So If you need to protect a ketone or aldehyde, protecting groups like the acetal or ketal are very useful. So hopefully that shows how we can use a protecting group in synthesis. So because that ketone group has a bunch of problems with either acetylides or the amide, we can protect it and then work with it. Because remember, ketals and acetals are base stable. They're not acid stable, but they are base stable. So NaNH2, strong base, will not affect our ketal here. All right, so that's an example of a synthesis using a protecting group.